get to choose their input mix to maximize their production efficiency. So input mix is chosen to maximize production efficiency. Maximize production efficiency, which equates to minimizing costs. Maximizing production efficiency equates to minimizing costs. Okay? So we talked last time about isoquants and the notion that isoquants were combinations of labor and capital that delivered the same output. Just like indifference curves are combinations of pizza and movies that deliver the same utility. Isoquants are combinations of labor and capital to deliver the same output. The key point is that technologically, any choice of labor and capital produces the same Q. So there's nothing that tells you technologically which of those to use. We just know technologically there's a set of choices which deliver the same Q. Well, how do we tell which to use? Well, we want to choose the one which is minimizing costs. So to do that, we're going to have to bring in the cost of those inputs. Just like we said there's a set of pizza and movies, all of which leave you indifferent. How do you decide which pizza and movies to choose? Well, you bring in the relative price of pizza and movies. Here we're going to bring in the relative price of capital and labor to determine how we choose between capital and labor. Okay? So to do that, we're going to draw isocost lines, which are going to be just like our old budget constraints. Isocost lines, which represent the cost of different combinations of inputs. Just like our old budget constraint represented the cost of different consumption goods. So if you look at figure 9.1, here we're going to have isocost curves, which are going to represent, and we're going to assume here that the wage is $5 an hour, and the rental rate is $10 per unit of capital. Okay? So in other words, the $50 isocost line in figure 9.1 shows all combinations of labor and capital that cost $50. So you could spend $50 in production if you had 10 units of labor and no units of capital, or 5 units of capital and no units of labor, or any combination in between. Okay? These are all the combinations of labor and capital that cost $50. Likewise, the $100 isocost is all combination of labor and capital that cost $100. Okay? So each of these isocosts give you the combination of inputs that cost a certain amount. Just like a budget constraint gave you the combination of pizza and movies on which you spent your income. Okay? Now, you may have said, well, wait a second, the difference with consumers, we knew their income. So we knew what their budget constraint is. Here we don't know whether to choose the $50 cost, the $100 cost, $150. We don't know what the total amount is. That's what makes firms harder. That's why we have an extra step. So hold that thought. We'll come back to that next lecture. Okay? For now, let's just say there's a set of trade-offs that the firm can choose from, and a set of isoquants that they have. And what's the slope of this isocost line? Okay? It's the negative of the wage-rental ratio. The slope of the isocost is minus W over R. The slope is minus W over R. It's basically the trade-off between labor and capital is going to be determined by the relative prices of those inputs. So the slope is going to be minus W over R. Okay? So basically, how many units of capital do you have to give up to get the next unit of labor? Well, what this isocost tells you, you have to give up 1/2 a unit of capital to get a unit of labor, right? So the slope is minus 1/2. Likewise, you could say you have to give up 2 units of labor to get 1 unit of capital. So that's why the slope is minus 1/2. Okay? That's what it's telling us. How much, it's once again, budget constraints are about opportunity costs. How much labor do you have to give up to get another unit of capital, or how much capital do you have to give up to get another unit of labor? Okay. Now, armed with isoquants, which are like indifference curves, and these isocosts, which are like budget constraints, we can then figure out what is the economically efficient combination of inputs for the firm to use. Okay? The economically efficient combination of inputs for a given level of output. So the economically efficient input combination for a given level of output is going to be determined by the tangency of the isoquant with the isocost, as you see in figure 9.2. Here we're going to use our same isoquant we had before, which is we're going to assume that Q equals square root of K times L. So same production function we had before, which gave a series of isoquants last lecture. Okay? So basically, what we see is that the efficient, if you want to produce a given amount, a fixed amount of Q, okay, then basically what you're going to do is you're going to say, so this, you're going to look for the tangency of that isoquant with the isocost, and you're going to say that the efficient way to produce that is going to be use 2.5 units of capital and 5 units of labor. Okay? It's going to say, look, given that the relative prices are given to us by this budget constraint, the production technology is given to us by this production function from which we derived isoquants last time. So the optimal combination of inputs to give this level of output is going to be 2.5 units of capital and 5 units of labor. Okay? And that'll produce, basically square root of 12.5. So basically, the quantity will equal the square root of 5 times 2.5, or the square root of 12.5 units of production. Okay? So basically, that is going to give us the efficient way to do that. Now, once again, as always, we want to think about things intuitively, graphically, and mathematically. Okay, let's think about for a second the mathematics. Okay, what is this? We know that the slope of the isoquant. We talked last time. The slope of the isoquant at any given point. The isoquant slope is the marginal rate of technical substitution, right? We defined that last time. The slope of the isoquant was the marginal rate of technical substitution, okay, which is the marginal product of labor over the marginal product of capital. And what we're saying is we want to set that marginal rate of technical substitution equal to the input cost ratio, W over R. Okay? That's what we're saying. The efficient thing to do is to set the marginal rate of technical substitution equal to the price ratio. Okay, that's what happens with the slope or equal. Okay? Now, once again, I find it easier to rewrite this equation. Once you develop the intuition, I find it easier to think of it this way. Rewrite this as the marginal product of labor over the wage equals the marginal product of capital over the rental rate. In other words, what this is telling us is the efficient place is where essentially for every dollar you spent on workers, you're getting the same return as a dollar spent on machines. The marginal product of labor over the wage is sort of the bang for buck of workers. Okay? What are you getting for your next dollar of wage? Okay? The marginal product of capital over R is the bang for the buck of machines. What are you getting for your next dollar of rent? And the efficient point is where these are equal. If they're not equal, then you have too much of one and not enough of the other.